This is Colin Harrison, and this is question 55 from section 3.7 in the Briggs textbook. So A says to use implicit differentiation to find dy dx of this equation. So we'll begin. Derivative of y times x squared plus 4 with respect to x is equal to the derivative of 8 with respect to x. This is just a product rule, so we take the derivative of the first times the second plus the first times the derivative of the second is equal to derivative of 8 is 0. So if we move this 2xy over, it's negative 2xy, and divide by this to isolate y prime, well, negative 2xy over x squared plus 4. And now B wants us to find the lines tangent to all the points where y equals 1. So at y equals 1, we'll plug that into here. We get this because we plugged in 1 for y. Then we have x squared equals 4. X is plus or minus 2. So that gives us the points negative 2, 1, and 2, 1. So then we need to find y prime at these points to find the slope. So we can make point slope form. So here we'll get negative 2 times negative 2 times 1 over negative 2 squared plus 4. That's positive 4 divided by 8 gives us a slope of 1/2. Whereas here we have negative 2 times positive 2 times 1 times positive 2 squared plus 4. That gives us negative 4 over 8. That's a slope of negative 1/2 at this point. So in point slope form, we get the following plus 2. Whereas here we have y minus 1 equals negative 1/2 x minus 2. And so this will result with the following plus 2. Whereas here we have y equals negative 1/2 x. That's plus 1 plus another one. So again, plus 2. So these are our two tangent lines. And then at C, it says to find an explicit expression for y and then calculate dy dx. So to find an explicit expression for y from here, we'll just divide 8 by x squared plus 4. Y equals 8 over x squared plus 4. And then take derivatives of both sides with respect to x. We will do derivative of y over derivative with respect to x equal to derivative of 8 over x squared plus 4 with respect to x. This is just a quotient rule kind of thing. So then you take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. And this will get us negative 16x over x squared plus 4. So then D, this was just, we went two different ways to find the derivative of this equation. So D just wants us to verify that these are in fact the same. So I will set them equal to each other. Negative 2xy over x squared plus 4. And here I notice that this expression does not have a y in it, whereas this one does. So I'm going to use what we found here, this explicit expression for y, and plug this in for y over here. So I'll say negative 2xy over x squared plus 4 equals negative 2x times 8 over x squared plus 4 over x squared plus 4. And that gives us negative 16x, and the denominator of the numerator just moves to the denominator. So that's x squared plus 4 squared. And that equals the expression we found here. So we have proved that they are equal.